This lecture will help you understand how to analyze the pulley, the inclined plane, and the screw. The wheel and axle makes it easier to move heavy objects. A wheel is a disc-shaped object of which the fundamental operation is to transfer linear motion into rotary motion. The wheel and axle can be considered to be a lever in which the radius of the wheel is the effort arm and the radius of the axle represents the resistance arm. The torque on the larger wheel must equal the torque on the smaller wheel, yielding the ratio of the resistance force to the effort force is equal to the ratio of the radius of the effort arm to the radius of the resistance arm. The mechanical advantage is the radius of the effort force axle divided by the radius of the resistance force wheel. Several examples of a wheel and axle are shown. A winch has a handle that turns in a radius of 30 centimeters. The radius of the drum or axle is 10 centimeters. Find the force required to lift a bucket weighing 500 newtons. First, sketch the problem. Write down what we know and the basic equation. The working equation solves for the effort force. Substituting what we know gives an effort force of 167 newtons. A pulley is a grooved wheel that turns readily on an axle and is supported in a frame. It can be fastened to a fixed object or to the resistance that is to be moved. A fixed pulley is a pulley fastened to a fixed object such as in A. A movable pulley is fastened to the object to be moved, such as in B. A pulley system consists of combinations of fixed and movable pulleys as seen in C, D, and E. For one fixed pulley, the effort is equal to the load. The effort force is equal to the tension in the cable. The resistance force is also equal to the tension in the cable and must equal the load. The mechanical advantage of a fixed pulley is equal to 1. The pulley changes direction of the effort force but does not reduce the effort force. For one fixed and one moving pulley, the law of simple machines is applied to the pulleys. The mechanical advantage is equal to the distance of the effort travels divided by the distance the resistance travels. When a weight is supported by two strands, each individual strand supports 1/2 of the total weight. For a single cable, the tension in the cable must be constant. Thus, the mechanical advantage is equal to 2. If a weight is supported by 3 strands, each individual strand supports 1/3 of the weight. If a weight is supported by 4 strands, each individual strand supports 1/4 of the total weight. In general, when a weight is supported by n strands, each individual strand supports 1/n of the total weight. Thus, mechanical advantage is n. When one continuous cord is used, this ratio reduces to the number of strands holding the resistance in the pulley system. Only in B does the effort force strand support the load. In all the other figures, the effort strand does not support the load and is not counted as a supporting strand. The two pulleys both have a mechanical advantage of 4. On the left is 2 fixed and 2 movable pulleys. The effort force does not support the weight. On the right is 1 fixed and 2 movable pulleys. The effort force does support the weight. What effort will lift the resistance of 480 newtons in the pulley system in the figure? Write down what we know and the basic equation. The pulley system has a mechanical advantage of 4. Solve the basic equation for the effort force. Substituting what we know yields an effort force of 120 newtons. There's a video on pulleys on YouTube from Blackboard that you can watch. An inclined plane is a plane surface set at an angle from the horizontal used to raise objects that are too heavy to lift vertically. Gangplanks, chutes, and ramps are all examples of the inclined plane. The work done on the resistance is equal to the work done by the effort. The work input is equal to the load times the distance traveled up the ramp, which is the length of the ramp, S sub E. The work done in raising the resistance using the inclined plane equals the resistance times the height the resistance is raised, S sub R. The mechanical advantage of the inclined plane is equal to the distance the load pulled up the ramp divided by the height of the load lifted above the ground. There's a video on ADA compliant ramps that you can find on Blackboard. A worker is pushing a box weighing 1,500 newtons up a ramp 6 meters long onto a platform 1.5 meters above the ground. What is the mechanical advantage? And what effort is applied? First, sketch the problem. The mechanical advantage is the length of the ramp divided by the height of the ramp, which is 4.00. To find the effort force, write down what we know and the basic equation. Solve the basic equation for the effort force and substitute in the known quantities to get an effort force of 375 newtons. A screw is another of our simple machines. Picture unrolling the screw, and what do you get? The screw is an inclined plane wound around a cylinder. The hypotenuse of the triangular section of the paper corresponds to the inclined plane threads of a screw as it is wound around the pencil. The jack screw, wood screw, and auger are examples of this simple machine. The distance a beam rises, or the distance the wood screw advances into a piece of wood in one revolution, is called the pitch of the screw. The pitch of a screw is the distance between two successive threads. The distance the resistance travels is S sub R. The effort distance is S sub E, which is the circumference of the circle made by the effort force, R2 pi, times the radius, R, of the screwdriver. Therefore, the resistance force times the pitch equals the effort force times the circumference of the handle of the screwdriver. The mechanical advantage of the screw is 2 pi times the radius divided by the pitch. Find the mechanical advantage of a jack screw having a pitch of 25 millimeters and a handle radius of 35 centimeters. Write down what we know, and the basic equation is the mechanical advantage of the screw. The working equation is the same as the basic equation. Solving for the mechanical advantage, we get a mechanical advantage of 88. A wedge is an inclined plane in which the plane is moved instead of the resistance. Finding the mechanical advantage of a wedge is not practical because of the large amount of friction. A narrow wedge is easier to drive than a thick wedge. Therefore, the mechanical advantage depends on the ratio of its length to its thickness. Examples of wedges are nails, the wood chisel, and the hatchet. A compound machine is any combination of two or more simple machines. Examples are an axe, a shovel, and scissors. Compound machines have a higher mechanical advantage because they are made of multiple machines. Simple machines have a small mechanical advantage, but work with a high efficiency. Compound machines have a high mechanical advantage, but work with a lower efficiency. The more complicated the machine is, the greater the mechanical advantage, but the lower the efficiency. To calculate the mechanical advantage of a compound machine, you multiply the mechanical advantage of all the simple machines in the compound machine. A crate weighing 9,500 newtons is pulled up the inclined plane using the pulley system shown in the figure. Find the mechanical advantage of the total system. What effort force is needed? The mechanical advantage of the inclined plane is the length of the plane divided by the height of the plane, which is equal to 7. The mechanical advantage of the pulley system is 5, the number of supporting strands. The mechanical advantage of the total system, the compound machine, is 35. To find the effort force, write down what we know and the basic equation. Solve the basic equation for the effort force and find the required effort force is 271 newtons. When we disregard the effect of friction, we have 100% efficiency, and the mechanical advantage is called the ideal mechanical advantage. Actual mechanical advantage, AMA, does take the effect of friction into account and recognizes that true efficiency is never 100%, but varies with the type of machine. The following are a set of problems for you to work on. Pause the video to give yourself time to work on the problems. First, a question. A pulley has 8 strands holding the resistance. The mechanical advantage is A, 4, B, 8, C, 16, or D, 64. The answer is B. The mechanical advantage is 8, equal to the number of strands. A pulley system has a mechanical advantage of 5. What is the resistance force if an effort force of 135 newtons is exerted? Pause the video to work on the problem. The resistance force is 675 newtons. Find the mechanical advantage of a jack screw with a 1.5 centimeter pitch and a handle 36 centimeters long. Pause the video to work on the problem. The mechanical advantage is 151. A farmer uses a pulley system to raise a 225 newton bale 16.5 meters. 129 newton force is applied by pulling a rope 33 meters. What is the mechanical advantage of the pulley system? Pause the video to work on the problem. The mechanical advantage is 1.74. If an effort force of 45 newtons is applied to a simple machine and moves a resistance of 270 newtons, what is the actual mechanical advantage? Pause the video to work on the problem. The mechanical advantage is 6. There are some additional example videos on compound machines you can find on Blackboard. Your assignments are to read Chapter 10 in the textbook and watch the videos on Blackboard. Your homework assignments are due March 23rd.